Werner H. Turgeon, Professor Emeritus UCLA. Specializations: Energy Budget Physics, Global Climatology, Urban Climatology, Bioclimatology and Photosynthesis of Plants, Models in Crop Water Budgets and Plant Growth for the World. No specialization in astrophysics, but I am conversant with the subject. Bubbles, certainty, and singularity. Ocean. A mind. Experiment. New knowledge to the experts. It is an attempt to show visually aspects of the existing knowledge of the astrophysics of the 21st century. This simplicity is an attempt to break through the firewall of mathematics and to make knowledge available to ordinary mortals. This knowledge is, after all, an understanding of the basics of existence, ours and of the universes. Cosmic singularity. Big Bang. First, some perspectives, in terms of energy, mass, momentum, and information. A brief exposure as to what is big and what is small. Hold that frame and study it for a while. The y-ordinate is time. The x-ordinate is size. In order to be more compact, we move the positives parallel to the vertical y-axis. We also move the negatives parallel to the y-axis, but below 1. The end result is one vertical axis, plus and minus sharing time and size. We start at the lowest size, at the Big Bang, at the beginning of time. Big Bang. The Big Bang temperature was extremely high, at 10 to the 32 degree Kelvin. Descending from the nano size, we have the beginning of quantum effects. This is the realm of uncertainty. Here, the Higgs boson, creating mass, might exist in the Higgs ocean. Beyond the nano level, we leave the quantum effects behind. We are entering the certainty of Einstein's relativity, tensor equations. As we move up, size and time increase exponentially, whereas temperatures decline. The age of the Earth is about 4.5 billion years. The age of the universe is 13.75 billion years. This is a combined and reduced graph, ranging from the Big Bang at the bottom to beyond the age of the universe at the top. In other words, it shows the entire story of our universe, from creation to the ultimate end. This is the final reduction. The red area at the bottom represents the Big Bang, the beginning of time in our universe. We will later connect other lines, which also originate at the Big Bang. Perhaps some viewers need to be reminded that the graph is logarithmic. This makes it possible to show extremely high and extremely low values on a single page. The highest temperatures, or at the Big Bang, near the Planck era. Here, time since the Big Bang is in less than yoctoseconds. This continues to the GOT era. At the electroweak era, we deal with picoseconds. Seconds dominate the particle era and minutes in the nucleosynthesis era. The nuclei era deals with 100,000s of years, whereas the atoms era and beyond is in billions of years. Temperatures are the inverse of the above. The lowest temperatures are at, today, the cosmic microwave background radiation, CMB, is at 3 degrees Kelvin. At the beginning of time, entropy is least, near the Big Bang. It increases from there to a maximum at today. Associated with entropy is the degree of organization of matter. The greatest or highest degree organization is at the Big Bang. Moving away from that time, disorganization increases. It reaches greatest disorganization at today. Of course, as the universe ages beyond our time, disorganization increases with it. As before, we will move the x-axis parallel to the y-axis. This makes the graph more compressed without losing data. Now comes the final compression and its connection with the previously constructed size and time graph, which has at its origin the Big Bang, or the beginning of time in our universe. The graph shows the results of applying Einstein's famous energy and mass equation for a series of mass examples. The y-ordinate is energy, ergs. The x-ordinate is mass, grams. Notice the great amount of energy released for just small amounts of mass. As was done in the previous graph of time and size, we will rotate the correlation line parallel to the y-ordinate, pairing energy and mass vertically. Now comes the final compression and its connection with the previously constructed size and time graph, which has at its origin the Big Bang, or the beginning of time in our universe. The light travel from Earth to the furthest observed galaxy is about 13 billion years. To the Andromeda galaxy, it took 2.5 billion years. To the nearest galaxy, Canis Major, it took about 25,000 years. To Alpha Centauri, it took only 4.37 years. To Voyager 1, it took 16.2 hours. To the Sun it took 8.3 minutes. To the Moon, it took 1.3 seconds. To the geostationary orbit, to Earth, it took 119 milliseconds, etc., etc. Moving the x-axis parallel to the y-axis resulted in this more compact data view. The universe is a place of constant motion. Nothing, absolutely nothing is motionless. Standing on the Earth's surface, we feel safe and motionless. This is an illusion. The reality is as shown. At the equator, the Earth's rotation is 1,600 kilometers per hour. The Earth rotates around the Sun at 107,300 kilometers per hour. The solar system moves around the Milky Way galaxy at 220 kilometers per second. Our galaxy rotates like a pinwheel at 630 kilometers per second. Finally, our galaxy clusters are moving toward the Virgo cluster at 967 kilometers per second. Moving the x-axis parallel to the y-axis resulted in this more compact data view. This takes some getting used to. Now, we experience the rotation of the Earth around the Sun. Now, we escalate the speed considerably by moving to the Sun galaxy rotation. This is the Milky Way galaxy. First, some orientations. This is a still of a rotating disk. Thus, a point on it is only a temporary location. We locate our solar system in the Orion spur. On it is our unfortunate human being. To be a citizen and voyager of the universe is not for wimps. Courage, little creature. Now, another and final leap. This is the movement of an entire galaxy cluster, including the Milky Way galaxy, in the direction of the Great Attractor, the Virgo cluster. First, we start with a simple aspect of information: spatial perception of astronomers during human history. It examines the worldview of the scientists and priesthood of an era, how they perceived the size of their world in comparison to the universe. During the Old Kingdom of Egypt, small settlements appeared in Lower and Upper Egypt. They were not just small themselves, but their view of the world was also very small. A few kilometers. By the time of Aristotle's concentric spheres ideas of the universe, at 2333 BP, the worldview had widened to the 100,000s of kilometers. Soon afterwards, the Ptolemaic geocentric system ruled astronomy for almost 1,500 years. This longevity was created by the Church, which preferred that Earth was the center of the universe. 369 years ago, Galileo spoiled this idyllic perception by the use of his telescope. The Sun was at the center, and orbits were elliptic. The mean distance to the Sun was 778 million kilometers. Isaac Newton, 1727 AD, visualized the whole solar system. Jan Ord, in 1950, saw the greater solar system by adding the Kuiper belt and the Oort cloud. The perception size increased into the trillions of kilometers. Edwin Hubble perceived the Milky Way galaxy and beyond in terms of light years. Today, the visible universe is about 93 billion light-years large and constantly increasing. It becomes apparent that many developments over time in nature and human affairs are exponential. The concept of information in astrophysics is the least intuitive. Recently, its conservation in a black hole was doubted by Stephen Hawking. This assumption was challenged by Leonard Susskind, who demonstrated that information was not destroyed inside a black hole, and it was preserved as a holograph on the wall of the black hole. A holograph gives the impression of a three-dimensional surface. Quoting Wikipedia, each point in the holographic recording includes light scattered from every point in the scene with the help of lasers, whereas each point in a photo has light scattered only from a single point in the scene. Professor Susskind maintains that the same concept applies at the frontier of the universe. But there is the problem of an exponentially expanding universe. Our current view of the visible universe is only a fraction of the total universe. The visible universe is an expanding bubble. The inside of it is isotropic. In every direction, we encounter a similar view. This means we are not near the border of the universe. At that point, we would observe an anisotropic universe with directional differences, e.g., we would see the border of the universe and its hypothetical holograph representing the entire universe. With our current technology, we will never see this, because the universe's expansion will outspeed our capability to observe the advancing frontier. It's like catching a rainbow. Inside the borders of the universe, information is not destroyed in a black hole. It is preserved in holographs on the wall of the black hole. The exponential behavior of information is demonstrated in the much-quoted Moore's law of transistor count doubling every 2 years. The modern problem of dark matter and dark energy. The matter we visibly see is termed baryonic. It turned out to be the least important. Non-baryonic matter occupies the majority of the universe. It was first observed in 1933. It became more prominent in the early 1970s, but was only well established by 1980. There are no clues as to its composition. It leaves its footprints by its gravitational effects. Currently, only 4.6% of mass in the universe is baryonic, whereas 23% is dark matter, and 72% is dark energy. The existence of dark energy was mentioned in the 1979's. Models attempted to examine it in the 1990s. Dark energy is everywhere in space, being the major force in the acceleration of the rapidly expanding universe. Determining this expansion is a major effort in astrophysics. The exact physics behind current modeling is still unknown. This is a visible presentation of the previous commentary and some more. We used a very simplified approach compared to the current lambda CDM model. All models have essentially two data points: the Big Bang after inflation and today, 2010. Accordingly, at beginning, 13.7 billion years ago, dark matter was 63% of the universe, whereas dark energy was near 0%. At today, 2010, dark matter had declined to 23%, while dark energy had grown to 72%. 2 points make a linear model. By simple correlation, the data were projected to the point where dark energy approaches 100%. This end was at 5.3 billion years in the future. Thus, the graph shows all of existence from Big Bang to Big Rip, where time ends. The idea of the Big Rip was presented in 2003. It hypothesized that ultimately all matter in the universe, galaxies, to subatomic particles, is ripped apart. At some time in the future, our universe disappears. Our simple, linear projection indicated that the universe would vanish at 5.3 billion years in the future. Estimates by a more complex modeling ranged through 7.5, 11.4, 22, 34 billion years. The average was 16 billion years. Our own backyard in our universe, the solar system. The rocky inner planets, Mercury, Venus, Earth, Mars, and asteroid belt. The gas giants, Jupiter, Saturn, plus their many moons, the outer Uranus, or planets, Neptune, Pluto, the larger solar system, the inner part, and the outer Kuiper belt. Even further out is the vast Oort cloud beyond this graph. The solar constant S equals E sub S divided by 4 pi d squared, where E sub S is the solar energy output, d is the mean Earth-Sun distance. 4 pi d squared is the surface area of a sphere. The highest value of the solar constant S is 9,278 watts per square meter. Venus has still a blistering S of 2,664. Both planets are considered to be outside of the life zone. Earth, S equals 1,395, and Mars, S equals 600, are within a surface life zone, whereas below surface life zones are a possibility for the moons of Jupiter, S equals 52, Saturn, S equals 15, Uranus, S equals 3.8, and Neptune, S equals 1.5. The higher probability moon candidates are Europa, Jupiter moon, and the Saturn moons of Enceladus and Titan. We define that universes are subsets of the cosmos. Then, some propositions. Time is an illusion. Reality consists of an infinity of event frames. Stacking up event frames in a sequence is like running a movie projector. At a certain speed, we perceive seamless motion and passing of time. The human mind is currently engineered in terms of beginnings and endings and ideas of creation. Realities are quite different. They are probabilistic on an infinite scale. The response is awesome. All the event frames exist all the time. Visualize an infinite matrix. That matrix has always existed. There is no beginning or end. No creation. It is literally everything. It always has been. We will try to visualize the infinite 3D matrix of event frames, or bubbles, all direction, x, y, z, and in infinity. Part 1, Metaphysics of Singularities. Propositions. A singularity is an uncertainty, chance event, and is scaled in probabilistic terms in percentages. That has long been accepted. Our changes have gone beyond this traditional concept. Singularities are everywhere, in geophysics and human affairs. In the latter, empirical hindsight, knowledge reigns. Foresight statements are speculations only. B. Time and cause and effects are illusions. A maker of singularities, which could be, for instance, astrophysical, black holes, big bangs, ratio matter versus antimatter, ratio dark matter versus dark energy, geophysical, asteroids, volcanism, biological, punctuated evolution, species radiation, cultural, seminal astronomical observations, belief systems and social revolutions, financial disasters. The Kurzweil singularity is biophysics. In order to avoid using the time word, X became forward and backward. Y became leftward, hindsight, and rightward, foresight. Z became upward and downward. Several statements seem to be in order. The only certainty is uncertainty. Singularities seem to be the agents of change in the cosmos. How do we quantify this? We use basic statistics, which withstood the test of time. The least, or less, probabilities are residing in the astrophysical sector. For instance, a Big Bang seems to happen only once at the beginning of a universe. Other, rare singularities occur in the universal constants, dark matter, dark energy, matter, antimatter. The geophysical sector has higher singularity happenings, but time intervals are still large. The biological sector is about halfway between the two extremes. The Kurzweil singularity is different in regard to its placement. It is both biological and geophysical, and, because of strong exponentiation, has been moved near the most likely probability location. The cultural and social sections have the highest singularity incidence. These singularities changed history from a monotonous sequence into a more punctuated and ever-changing panorama. The sciences might want to refocus on the study of the many natures and types of singularities. So, folks, get out of your self-indulging certainty boxes and be buffeted by the winds of change and uncertainty. The writing is not on the subway wall, but is on the Facebook and Google Plus walls. We are dealing with extremely large differences in size. The range extends from infinity, the cosmos, to tiny subatomic particles, to about 10 to the minus 30. Below the cosmos, in contrast, the big players, universes, have the least probability in the formation of singularities, whereas the opposite is indicated among the tiniest of particles. The tail is wagging the dog. Thus, the greatest uncertainty is governing the formation of infinite realities. The cosmos is infinite. It has no beginning or end. It always was there is, or was, no creation. It is everything. It contains every possible probability. Even the most bizarre realities have at least one occurrence. Universes are born by big bangs of an infinite number, all possible types, durations, universal constants, and sizes. A constant, ever-ongoing, bubbly change. Where is our current universe in all this? Clustering is a key feature in a universe's modification. Singularities. Clustering can be firstly nebulae, secondly galaxies, thirdly supernovas, fourthly stars and solar systems, and fifthly planets and inclusions. There are many types, sizes, and many reclusters. More reclusters result in increasing number of elements, including those which make life possible. Universes which are clusterless are drastically different from our own universe. There would be no galaxies, stars, etc. So, it is important to clump or not to clump. That is the question. Here is an example of a preplanetary nebula. Again, there is an infinite number of nebulae, types, and sizes, as well as universes without nebulae. Black holes and galaxies. The first, singularities, or black holes, of varying sizes and types. The responses, or galaxies, which are clusters of stars, star remnants, gas, dust, clouds, and dark matter. There are many sizes of galaxies, dwarfs of only 10 to the 7th stars to giants, 10 to the 14th stars. There are also large gaps where only gas, dust, and cosmic rays exist. Black holes are the drivers of mass and momentum motions. Another powerful actor is dark matter, which is about 90% of the galaxy's mass. This massive gravity keeps the system together. There is an infinite number of black holes, galaxies, types, sizes, and inclusions. Supernovas can be recyclers of previous nova singularities. There are novas and supernovas. The latter is much more extreme and visible throughout a galaxy or beyond. The explosion shockwave moves at 10% of light speed into space. There are types 1 and 2 and their subdivisions. The former is an old star that collapses by gravity into a neutron star or black hole. Type 2, a white dwarf, inputs material from a neighbor star, rising its core temperature into a runaway nuclear fusion. It appears that supernovas average every 50 years in our galaxy. But no supernovas have been observed since 1604, since Kepler's observation. Supernovas too close to our vicinity in our galaxy could be very destructive. Several paleogeological extinction events have been traced to deadly gamma-ray outbursts. Again, there are an infinite number of novas, supernovas, types, sizes, and material recyclers. Star formation in the Rolf-Dioichy cloud. Spitzer Space Telescope, IRAC, MIPS, NASA, JPL Caltech. Star systems are subsets of galaxies and supernovas. They range from single, binary, triple, quadruple, quintuple, sextuple, to septuple. The most common systems seem to be single to triple. All are held together by gravity. Sizes range from tiny to very large. There are an infinite number and sizes of stars and solar systems. Planets and inclusions. Planets and their inclusions are subsets of solar systems. The inclusions range from moons, asteroids, comets, meteoroids, meteors, dust, and human detritus. Sizes range from tiny to large. There are an infinite number and sizes of planets and their inclusions. Human egg cells are subsets of all bioorganisms. They are the smallest building block of life. About 10 trillion cells are in an average human. Cells can range between 1 and 100 micrometers. Prokaryote and eukaryote cells are the basic types. Both have many inclusions, including DNA, RNA, and organelles. There is an infinite number of sizes and types of cells. Water molecule H2O. Molecules consists of several atoms in an electrically neutral group, held together by covalent chemical bonds. They may contain atoms of a single element like oxygen, or different elements like water. Organic substances are common in the atmosphere and oceans. The majority of molecules are very small. For instance, the smallest molecule is diatomic hydrogen, H2, which equals 0.75 times 10 to the minus 10 meters. Most molecules are several times larger, up to a dozen of that number. It is not surprising that there is an infinite number, sizes, and types of molecules. A depiction of the atomic structure of the helium atom. The darkness of the electron cloud corresponds to the line of sight integral over the probability function of the 1-second atomic orbital of the electron. The magnified nucleus is schematic, showing protons in pink and neutrons in purple. In reality, the nucleus and the wave function of each of the nucleons is also spherically symmetric in 1 second, and the 4 particles, each with a different quantum number, like the electrons in the helium atom, are almost likely to be found in the same space at the exact center of the nucleus. In simpler terms, we have entered the quantum uncertain size section. Here, uncertainty reigns. Thus, an electron's speed and/or location cannot be determined at the same time. Statistical physics have to used to determine probabilities. This realm of probabilities is the mother of an infinite number of sizes, types, and, yes, probabilities. Electrons, protons, and neutrons. The smallest of the small. This is the grandmother of an infinite number of sizes, types, and probabilities. If we use the scale given to the neutrons and protons, then the quarks and electrons are less than 0.1 meter in size, and the entire atom is about 10 kilometers across. This means that almost all of the atom is just space. Our reality is empty space. The statement, bubbles within bubbles, needs some clarification. A clearer term for academics would have been subsets within subsets. Yet, for the general public, the bubbles term is perhaps more understandable. So, the subsets to the infinite cosmos are universes. Ours is one of them. Compared to the other subsets to follow, they are large. Each universe has many subsets of nebulae, which are quite smaller than the previous subsets. Nebulae have subsets of black holes and the associated galaxies, another size, decline. And so it goes. Subsets get smaller and smaller, ultimately to very small. It appears that the general public's perception is limited to solar systems, to planets, and to cells. The other categories are not well understood. Computational considerations. The basic algorithm for physics singularities is the function of probability of a singularity event, kurtosis, skewness, size. This means, among other things, that we are not just using regular, bell-shaped curves, also several deviations from that norm. Also, we are considering the nature of the curves themselves. For instance, the two parts of the curve of less than 13.6%. These are foreshocks and aftershocks, meaning that some events develop which lead to the following singularity, as well as aftershocks of a singularity which could be considerable and lengthy. Example of foreshock and aftershock for a bell-shaped curve. Example of a possible singularity coalescence in a two-dimensional environment. Notice that in this case, the singularity surface does not reach zero. This may not be always the case. Example of a possible singularity coalescence in a three-dimensional environment. Here, most of the singularity surfaces stay above zero. We are giving an example of a possible distribution of sizes and their probability to be chosen by chance. This was not a real simulation. The idea behind it is that the largest sizes will have lowest probabilities to be selected, whereas the smallest sizes will have the highest probabilities to be selected. The values we are using are rough averages. In reality, many of the items have large deviations from the used averages. A world, universe, galaxy, plants, human affairs, etc. would be a featureless tabula rasa and monotonous, really boring. Singularities, SI, take away this monotony. It is the creation of the many features we are used to see. An example of 3D geophysical system, a combination of determinism, certainty, and singularities, uncertainty. 1. Size relative percent. The bigger the size, the smaller is the percent of being chosen. This inverse system is deterministic, deductive process response, white box certainty. It contains leftward hindsight, empiricism. It is non-monolithic. Its most deterministic sector is in the physical biophysical, hard sciences, whereas the social sciences, arts, and humanities sectors show an increasing softness. Nevertheless, the examined life is preferred over speculations based on ignorance or superstitions, e.g., faith-based certainties of extremist religious, cultural, and political belief systems. The former sector goes under the rubric of academia. In spite of its apparent influence in modern society and in considering that the human population is almost 7 billion, the size of academia in it is tiny and still further diminishing. This is because the vast populations of the Third World are poorly educated and ignorant. This portion of the human population has had always a much higher birth rate than the industrial world. This is not a static situation. The earliest mathematical attempts in geometry and algebra appeared in the antiquity. Yet, by far, the vast public sectors were totally ignorant and steeped in superstitions and controlled by theocracies and/or monarchies, using an active priesthood to control their subjects by keeping them ignorant. Only with the dawn of the Industrial Revolution, 1712 AD, did we have the beginnings of modern science and development and associated profound social impacts, including Bismarck's compulsory education of the masses. But the percentage of educated people versus the uneducated keeps on widening exponentially. It is a function of their larger birth rates, lower infant mortality, increased influence of fundamentalist religious anti-science efforts in schools dedicated to indoctrination to keep students obedient to its tenets and mores. Virtually all the major organized religions of the world have schools of this nature. In addition, one should not underestimate the impact of Luddism and its rejection of anything new or different. There are other problems impinging on the education of the masses, even, if not especially, in the industrial world. Twitter, and a large number of other social networks supply an exponential vast amount of information of the blandest quality. But information is not knowledge. To be fair, professionally it could be the first step, empirically, in the eventual evolution of actual knowledge, complete understanding, not memorized information. Consequently, we experience many changes in this supposedly deterministic and certain sector. Is there even uncertainty in certainty because of continuous changes? Determinism has a frazzled edge of trying to predict the unpredictable, i.e., chance events. Creation of singularities. Dark blue is less than 1 standard deviation from the mean. This is about 68% of the set. 2 standard deviations from the mean, medium and dark blue, account for about 95%, whereas 3 standard deviations, light, medium, and dark blue, account for about 99.7%. Originally, other shape factors beyond the bell-shaped versions were investigated. Kurtosis and skewness. Positive skewness. Negative skewness. J-shaped. Reverse J-shaped. Bimodal. Multimodal. But we found them not compelling enough for use at this time. Singularities are totally disconnected from determinism. They simply do not know of each other. They are in the realm of the throwing of dice. As an example, every person, or any event at any scale, is a singularity, created by chance. They may be very small and unimportant or very large and important. Predictions of uncertainties, singularities, may not be very productive. Of course, a certain probabilistic prediction will reoccur eventually. But how meaningful is this? We have to learn to think in terms of singularities in all of the disciplines. This will take some experimentation by experts in various disciplines. In this mind experiment we are only pointing at all the possible ways to influence future research in the different fields to think in terms of singularity creation and existence. There is a singularity ocean in 3D. A crude analogy would be islands and continents of determinism floating in the singularity ocean of uncertainty. They are oblivious of each other. Observational evidence. The evidence is all around us. There is a frazzled edge around determinism, the inability to be completely precise. Everywhere, in the hard and soft sciences, we find events which are not predictive. They just happen. The unpredictable earthquake, or stock market, or elections, or disease, or Beethoven, or the Beatles. And the beat goes on. And what is unpredictable and unknowable? Singularities. The height and shape of singularities also applies to the soft sciences. For instance, in history the height of a singularity is determined by the percentage of the relevant public which is aware of an event or events. Below is a demonstration of the possible shape of singularities in regard to the French Revolution. This portrayal is strictly speculative. At the human level, we are all walking singularities. Virtually every moment in our daily hurly-burly is created by the throwing of the dice. Are we getting up at exactly in the morning? What do we do next exactly? It goes on ad nauseum. Seemingly, these are not important events, but many are or could be. The power of dice throwing is fundamental and enormous. This is an example of the application of a sequential arrangement of the preceding French Revolution demonstration example. The bars represent the various sizes, heights of each singularity, the center of each bell-shaped curvature. The red bar stands for the French Revolution singularity. The tan-colored bars stand for singularities from the left ward to the right ward in regard to the French Revolution singularity. In the bell-shaped mode, it might have looked like this. Notice the coalescing bases of the singularities. Another way to present and show singularities is in a geographical arrangement. Again, we are using the French Revolution data as a demonstration on a map of North America across the Atlantic to Europe, ending in European Russia. Redefining uncertainty. So far, the tradition of treating uncertainty, singularity as statistical entities has been followed. This isolated the concept of uncertainty from the rest of the sciences. Now, this thought experiment of uncertainty is semantically redefined in relativistic terms. It becomes part of the space-time continuum by defining it as the weight of uncertainty bearing down on us. Similarly, Newton's force of gravity was redefined by Einstein as an effect which depresses space-time. So does relativistic uncertainty. RU. The units of RU are kilogram times meter squared times seconds squared minus 2. Initially and experimentally, RU is related to each probabilistic percent that corresponds to each percentage point, 1% to 99.9%, or 1 RU to 99.9. There could be multiples of this, later to be explored. Consequently, one can state now, determinism plus relativity plus uncertainty equals 0, or certainty plus uncertainty equals 0. This expression is deceptively simple, hiding a massive amount of possible calculations. The devil is in the details. This system of equations in energy, mass, momentum, and RU creates an environment of physical and social viscosity similar to Einstein's treatment. Everything in the cosmos, with multiverses, experiences viscosity. There is no true vacuum. It becomes a non-compressible fluid, with possible time dilations of mass increases, contractions in the direction of travel, and the slowing down of time. High viscosity, e.g., Muddism, socio-religious certainty, effects of gravity, etc. slows down momentum, be it physical or cultural. Computational considerations. Total certainty is the antipole of total uncertainty. The latter begins at less of the nano-level atoms, the realm of quantum mechanics. This has been treated before. The regression equation y equals -8 times e times minus 31 times x plus 0.8 predicts this relationship between the two poles. In the Cartesian diagram, x is the size in meters, whereas y is the uncertainty. Total certainty, or total determinism, may need some definition and/or explanation. A process-response system, situated on a slope, is used to explain the forces of energy, mass, and momentum acting on this selected cube. A human-related graph portrays the extremes of human total ignorance to total knowledge, using Kurzweil's Homo erectus idea of exponential development of knowledge. The agricultural revolution, about 10,000 years ago, began the first settlements in the opportunity of learning. The remaining Homo sapiens are thought to be undergoing the geometric development, climbing gradually through the ages. The two curves were virtually the same for many centuries, and began to diverge since the Renaissance. Yet, there are numerous current scientists which view the future in geometric terms. The exponential regression curve is y equals 0.0490 times 1.5009 times exponent x. As seen by an outside observer, this graph deals with the relativities of time dilation, time increases, length contraction, and mass increase. All three react to velocity increases. At slow speeds, Newton's laws are still reliable, but at speeds more than half the speed of light, time dilation increases exponentially. It approaches 1, never to reach it. Length contraction is in the direction parallel to its motion. This shortening of length is the Lorentz transformation. It approaches 1, but never reaches it. Mass increases act similarly. It increases to approach infinity, but never reaches it. Thus, one cannot exceed the speed of light. The exponential curvature is the same as used in the previous Homo erectus graph. This graph had been derived differently, based on simple assumptions. Wikipedia shows the basic tools of the Navier-Stokes general equations, which are often used to solve for the viscous space-time effects. The literature offers various methods for finite difference solutions for these equations. Final remarks. It is realized that the results of the thought experiment or somewhat radical. Because of this, it will undergo an almost automatic, negative, laddic rejection. The bell-shaped curve indicates at least a 50% rejection. Under the best of circumstances, the next, following continuum, will be from mere tolerance, to mild acceptance, to full acceptance. Academic folks will have a hard time to assimilate the use of singularities or unknowables as constant uncertainty companions in everyday life, and in the sciences, the singularity ocean. This would have affected the social sciences, and especially the humanities, arts, etc. I have to admit that all of this did not come to me easily. My background has always been deterministic. I did my mind experiment, one step at a time. There was no agenda. Logic just drove me to it. Uncertainty. The idea that, for example, at the human level, we are all walking singularities is a hard one to swallow. Let us face it, virtually every moment in our daily hurly-burly appears to be created by the throwing of the dice. Are we getting up at exactly in the morning? What do we do next exactly? Seemingly, these are not important events, but many are, or could be. The power of dice throwing is fundamental and enormous. Consider how this is received among the certainties of the religious, political, cultural, devout. It is dynamite, but the search for realities cannot ignore uncertainty. We cannot say, "Not in my backyard." All these considerations drove me to examine the possibility of divorcing the idea of uncertainty from statistics, to be able to communicate with the deterministic universe and cosmos. To achieve this goal, uncertainty was redefined as relativistic uncertainty, U sub r a, weight with mass and momentum bearing down, having the same units as the relativistic universe cosmos. For convenience, RU is relabeled into U sub r. This led to determinism plus relativity plus uncertainty, U sub r equals 0. Since the first two items are based on certainty, it becomes certainty plus uncertainty, U sub r equals 0. It attempts to put all knowledge under one umbrella. Initial results show that U sub r can change from maximum 1 to minimum 0. It is a subject to time dilation, mass, and length changes, just like certainty. U sub r is independent of the assumptions that time and cause-effect are illusions. Some may consider this presentation as rambling. My apologies. In this piece, I am trying to reach two populations: academia and the general public. The latter is by far the largest in numbers worldwide, including the industrial countries. Scientific ignorance is legendary. People and their elected representatives make choices in scientific subjects with ignorance and are not mindful of the dire consequences. The perspective part of the video introduces to the public ideas of what is very small to what is very big, using scientific notation. What is energy, mass, momentum, and information? These sections are strongly graphic and contain bits of metaphysics. The series of bubbles within bubbles is a typical example. It is hoped that some of the mysteries concerning the sciences can be better understood and appreciated. A much shorter version aimed at academia is considered, if needed. Remember, folks, I am just pointing, not giving final resolutions. That is up to you, the smart and open-minded. Tally ho, Werner. Final remarks. This is to clarify some of the impacts and consequences of assuming time and cause effects being illusions. By the way, this position was not created by me. Several noted astrophysicists have proposed it before. As stated, the cosmos and its infinite number of universes has always existed. There is no beginning and no ending. There was no creation. Everything just is. Everything that has happened has already happened. Every possible reality exists, even the most bizarre or exotic realities which are so extreme, from our viewpoint, to be beyond imagination to exist, at least in one reality. Let's explore beyond our narrow event horizon. Consider other sentient, intelligent beings. They exist partially because they do anyway, and partially we can imagine them. Their thought systems may be grossly different from ours, yet they also exist. Multiply this phenomenon by numbers approaching infinity. The results are colossal and sobering. Humanity's imagination systems of possible realities are tiny compared to all the other realities. Think of a reality, and it exists. Let's explore further. Folks who are certain about their religion, their politics, their culture, and their superior race. And finally, scientists who are so very certain that they will not brook any contrary opinions or observations. The latter, and their students, have invested in a theory that must be defended at any cost. They have painted themselves into a corner. All of such realities do exist, odd they may be. For instance, there would be planets, solar systems, galaxies, etc. that are Christian plus subsets, Muslim plus subsets, Buddhist plus subsets, etc., etc. Any nightmare ever invented by the human mind or alien minds exists as at least as one reality. So, be careful out there.